In this lesson, we're going to look at how to write regular expressions using metacharacters. And I'll explain what metacharacters are as soon as we start our program. So let's go ahead and get started. We're going to call this program regex2.java. A metacharacter is a shortcut for a character class. So for example, \w is the metacharacter for a word. \d is the metacharacter for a digit. And \s is the metacharacter for a space. And we're going to look at how to use all three of those in this lesson. So let's get started. First thing we need to do is import java.util.regex.star. And we'll start our program. It will start out similar to the program we had before. Here's our string that we're going to examine. Here's our pattern. And for this first one, we're going to do the word metacharacter. The next step is to compile the pattern, then create a matcher object. Then we're going to display the text or the string. Then we'll begin to examine what words match our regular expression. So let's write a couple of system out print line statements. And this looks just like our program from the last lesson. So let's compile. And then run it. So you see that it matched every single character. So we're just a little bit off with our regular expression. Also, I should mention that notice in the pattern that we have to put 2 backslashes. Again, that's because we can't let the compiler assume that we're trying to write a special string character like \t or \n. So we double backslash our regular expression metacharacters just like we double backslash the new line character, for example. But now, getting back to the problem, this matched every character in the string. What we want to do is have it match groups. So what we need is to add a quantifier, the plus right here. So by doing that, let's go back to our program, clear the screen, compile, and then run. There we go. It matched 90% effort, 100% of the time. The different words, although 90 and 100 are numbers, that are part of that string. And understand that the \w metacharacter will match any A through Z or 0 through 9 character. Now, the metacharacter for digits is D. So let's give that one a shot. We'll change it to D, save our program. We'll leave all that output there. All right, so you see we have the same problem. With \d, it matches every digit. What we want it to do is match groups of digits that make numbers. So what we need to do is we go back to our regular expression and put the plus quantifier in. Now let's try it again. Clear the screen this time. Compile, and then run. And here you see it matched our 2 numbers, 90 and 100. So let me do one thing here. Let me add a commented out pattern for the word pattern. And then we have the digits. Let's comment it out also. And now let's look at spaces. If you check back in our string, you'll see we have 1, 2, 3, 4, 5, 6, 7 spaces. So now we don't really care about where the spaces are, at least for this output we don't. What I want to know is how many spaces we have. So what I'm going to do is I'm going to comment out the while loop that displays the matches, add a count variable, and then for every find, Every time we find a space, increment count by 1, and then we'll display how many spaces there are. And again, we counted 7 in our string. So let's clear the screen, compile, and then run. 1, 2, 3, 4, 5, 6, 7, and total spaces equals 7. So to wrap up this lesson, we've learned about metacharacters, at least the beginnings of metacharacters. And we looked at 3. The regular expression to match a word using the metacharacter \W, the regular expression to match a number using the metacharacter \D, and the regular expression to match a space using the metacharacter \S. So that wraps up this lesson on metacharacters, and we're going to move to the next lesson, which is a little more practical, where I'm going to demonstrate how to use regular expressions to replace substrings in a string.